This is Geometry, Section 7.2, Similarity. So, we've been talking about ratios and proportions. So similarity has to do with when we're talking about shapes that are proportional to each other. So, to start off, if I have that the ratio of GB to GS, so these two sides in this rectangle, is 5 to 4, and the perimeter of the rectangle is 108, then I need to find the length of HB and the length of HS. So, HB would correspond to GS, so if this was a 4, then that would make this a 4, and same thing if this is 5, SH would be a 5. However, if we add up 5, 5, 4, and 4, that doesn't give us a total of 108. So, what we have to do here is figure out, okay, we took this ratio from this side to this side. Let's say it was 30 to 10. If the original ratio was 30 to 10, then that would mean we have a side of 30, 30, 10, and 10, and our original perimeter would be all of those added up, so it's going to be 60, 70, 80. But if I had a ratio of 30 to 10, we wouldn't leave it as 30 to 10, we would reduce it to 3 to 1. So that's what we have to figure out here. This ratio was reduced by something, and we have to figure out what it was reduced by to get us back to a total of 108 when we add up all the sides. So we'll just call that number that we reduced by x, because we know it has to be the same thing for all of them. Get rid of these. So if I add up all of these sides now, 5x plus 5x plus 4x plus 4x, I want all of that to equal 108, the perimeter. And then we need to figure out what x is so that that gives us a total of 108. So if I add up all these, I get 18x equals 108. When I divide, that leaves me with x is 6. So if I plug that back in to each of these sides, this side and this side are going to be 5 times 6, which is 30. And these two sides are going to be 4 times 6, which are 24. And if we add up 24, 24, 30, and 30, it does give us a total of 108. So HB would be 24, and HS would be 30. Similarly, if I give you the measure of the interior angles of this triangle are in the extended ratio 1 to 2 to 6. Now, we're not used to seeing three numbers in a ratio, but all it means is when I compare this to this to this, the comparison is 1 to 2 to 6. It's still just a comparison. So again, we don't know what needs to be multiplied by these numbers in order to get us the total that we need, which, since we're talking about angles in a triangle here, we need these to add up to 180. But 1, 2, and 6 don't add up to 180. So we need to multiply them all by something, we don't know what that is yet, to get us to a total of 180, but still keep the ratio the same. So 1x plus 2x plus 6x needs to equal 180. This added up gives me 9x. When I divide, I'm left with 20. So it's asking me to find the measure of the three angles. Well, if x is 20, and I plug that back in to these three spots, I get 20, 40, 20 degrees, 40 degrees, and 120 degrees, which does add up to a total of 180. So, similar polygons, what are they? If we look at these two triangles right here, it appears that these triangles have the same angles, but they definitely have different sides. So it's not like when we were talking about congruent triangles where everything is the exact same, because the sides of these triangles are definitely not congruent. This one is clearly smaller than this one. So these are called similar triangles, and we write that triangle CAT is similar. Instead of the congruent symbol, which is this, the squiggly with the equal sign under it, we just write the squiggly sign. That means similar. So triangle CAT is similar to triangle DOG. And notice that we have to match up the corresponding letters. So C matches up with D, A matches up with O, and T matches up with G. Just like when we were working with congruent triangles, we have to match up the corresponding letters. So similar polygons have all angles congruent, and the sides of similar polygons are actually going to be proportional. So proportions we talked about in the last section. That just means that if I write a ratio between two of the corresponding sides, it's going to be the same for any two corresponding sides. So in other words, the ratio of A to X is going to be the same as the ratio of B to Y, and that's going to be the same as the ratio of C to Z. All of the corresponding sides need to be proportional. So down here, again, the order that I name these two triangles matters. So A is going to match up with Q, B is going to match up with P, and C is going to match up with R. So to start off, we've got a 90-degree angle right here at angle B, 28 degrees at angle A. So to find angle C, we add up 90 and 28. Gives me a total of 118, and I subtract that from 180 to get angle C, which is 62 degrees. So now I have all three angles in this triangle. We'll fill in that angle C is 62. So now to find these two angles, I just have to figure out which angle they match up with on the other triangle. So B would match up with, like we said, P, and those two are already matched, so B and P are both 90 degrees. A is going to match up with Q, so angle Q is going to be the same as angle A, which is 28, and R is going to match up with C, so that's also 62. Now, the sides is where it becomes a little bit trickier. We need to find AB. We don't have a measurement for it, so let's just call it X for right now. So if this is X, we need to figure out which side this corresponds to on the other triangle. So if we look at this statement, A and B are the first two letters, Q and P are the first two letters. So those two sides are going to correspond. So X is going to correspond to QP, which is 30. So what we want to do is we want to write a proportion similar to this one up here. So we want to write a proportion between two pairs of corresponding sides on each triangle. But what we want to make sure of is that in one of the proportions, we have two numbers and not a variable. So we have to look at this here. So if I look at AC, I have a number for that one. I know that that's 51. So now I have to look at the other triangle and figure out, okay, do I have the corresponding number for this side of the triangle? Well, A is the first letter, C is the first letter, Q is the first letter, I'm sorry, C is the last letter, Q is the first, R is the last. So AC would match up with QR. QR is right here, and I do have the number for that one. I have 34. So since we went from the big triangle to the small triangle, we're going to set this equal to another pair of corresponding sides, 51 and 34. And now, just like we did in the last section to solve a proportion, I just cross multiply it. So 30 times 51, 34 times x, 30 times 51 is going to give me 1530. And when I divide that by 34, I get that AB is 45. So same thing for RP. RP, let's just call it Y, make it simpler. So if this is Y, we need to figure out what it matches up with. So R and P are the second and third letters. B and C are the second and third letters. BC matches up with RP. So we're going to write 24 over Y for this one. And then we can still use the same pair that we used for the other one because this is still true. This would make a true proportion. Because these two sides, 51 and 34, still match up. So now I'm trying to find this missing side so I can still match it up with the two sides that I have that correspond. So same thing, cross multiply, 51y equals 24 times 34, which is 816. And when I divide, we get that y is 16, which was RP. So RP is 16. All right, on the back, it says the two quadrilaterals are similar to each other. So we're mostly going to work with triangles in this chapter, but any kinds of shapes can be similar to each other. Quadrilaterals, pentagons, hexagons, etc. So these two quadrilaterals are similar. We need to figure out what x, y, and z are. So we need to figure out what sides they match up to. So x, y, and z are here. So we need to write correct proportions to solve for those variables, just like we did for the triangles. So if I look at this, y matches up with 12, x matches up with 27, z matches up with 15. But these sides match up with each other, and I have numbers for both those. So that's what we want to compare everything to when we go to write our proportions. So I know that 45 compares to 30. And even more than that, we can reduce this because both of these numbers can reduce by 15. So that can even reduce further to 3 to 2, and that makes our proportions even easier to solve. This is something called a scale factor, which we'll talk about down below. So a scale factor is just the ratio of one shape to another, one similar shape to another, the relationship between the sizes of the two things. So if I'm solving for x, for example, we said x matches up with 27. So if we go big to small for all of our proportions, because we have to go in the same order, then we're going to write 27 over x. 27 compared to x is the same thing as 45 compared to 30, which is the same as 3 over 2. So when I cross multiply that, you would get the same thing, by the way, if you left it as 45 over 30. It just makes it easier numbers to multiply if you reduce it to 3 over 2. So if I cross multiply this, I get 3x equals 54. And when I divide by 3, I get that x equals 18. Same thing for y. Y is on the bigger shape, so we're going to compare y to 12. Y compared to 12 is the same as 3 compared to 2 again. Cross multiply, you get 2y equals 36. When you divide, y equals 18. And finally, for z, z compares to 15. 15 is on the bigger one, so we're going to write that first. 15 over z is the same thing as 3 compared to 2. Cross multiply, 3z is the same as 30. When we divide by 3, z is 10. All right, these two triangles. So we're finding the small height, small base, small hypotenuse, big hypotenuse, small perimeter, big perimeter. So hypotenuse, if you don't remember what that is the side across from the 90-degree angle in a right triangle. So that would make the height and the base the other two sides. Since this one's going vertically and this one's going vertically, we'll call those the heights, and the ones going horizontal the bases. So the small height is 12, the big height is 21, and we'll reduce these in a second. Small base is 16, large base is 28. Small hypotenuse, 20, large, 35. Perimeter, if I add up all three of these numbers, 12, 20, and 16, I get 48. If I add them up on the big triangle, I get 84. So let's reduce these. 12 and 21. 3 goes into both of those 4 times and 7 times. So the ratio of the small height to the big height is 4 to 7. Now, the ratios of all the corresponding sides should be the same. So if we check these, all of these should reduce to 4 over 7. 16, 28, 4 goes into those 4 and 7 times. 20 and 35, 5 goes into those 4 and 7 times. Perimeter. So this is all the sides added up. This one we can reduce by 12 also. Becomes 4 over 7 if I reduce each of those by 12. 12 goes into 48 4 times, goes into 84 7 times. So this proves our next point, that if two polygons are similar, then the ratio of their perimeters equals the ratio of their sides. So if you want to know the ratio of the perimeters of two similar shapes, you don't have to actually add up all the sides. You can just find the ratio of any two of the corresponding sides. And finally, scale factor, like I said. Scale factor for any shape is really just a fancy word for the ratio of any two corresponding sides. So in the example we did above, the scale factor of that small triangle to the big triangle would be 4 to 7.